Question 4. Find the optimal additive seasonality model to predict sales for time period 5 to 20 and calculate MAD, MAP, and MSE. Here we have a list of 5 formulas. Let's see how these formulas work. First of all, some notations. E means level, or sometimes people call that base level. They are in our column E. And S is called seasonal factor. They are in our column F. And YT hat, as usual, is forecast. They are in column G. And then H column we have forecast error, and so on and so forth. Additive seasonality model is complicated. A key reason is this guy P. And what is P? First of all, let's look at our data. We have collected sales information from the previous 4 years, right? But information we collected over here is quarterly data. Well, we all know 1 year has 4 quarters. And this is something very, very common in many business. It's called seasonal phenomenon. What do you mean by that? For example, for products like Christmas cards, we are not going to buy Christmas cards, say, in May or in August. Chances are people will buy pretty much all the Christmas cards they want right before the Christmas. So most likely it's going to be in November and December. And you see this pattern repeats itself year after year. So this is what we mean by seasonal phenomenon. And in auto sales, we also have this kind of seasonal phenomenon. Here we have quarterly information. So you can imagine, for example, in order to predict the sales of quarter 2 in 2011, chances are the best indicator might be from the sales of quarter 2 in year 2010, because here we are talking about the same quarter, well, of different years. And that's where P comes into play. P here is nothing but the number of time periods in a cycle. Most of the time, a cycle is 1 year. Here, the time period is quarter, and 1 year has 4 quarters. So P is equal to 4 in this case. In many, many cases, we might be using, say, monthly information. Well, we all know 1 year has 12 months. In that case, P will be equal to 12. All right. If you look at the formula for calculating the level E and the seasonal factor S, we see things like subscript T minus P. For example, if we want to calculate base level of time period 1, and T minus P will be what? 1 minus 4, which is negative 3. It cannot be done, right? And that's why we have the first 2 formulas for initialization. Okay, here's how it works. Because P is equal to 4, 1 year has 4 quarters, we cannot calculate base levels for time period 1, 2, 3, and 4 using the regular formula over here. Instead, here's what we're going to do. We're going to use the first formula. The first level will be equal to the average sales of the first year, or of the first 4 quarters. And we're going to use this level for time period 2, 3, and 4 as well. And the reason is similar. We don't have enough information to use formula 3 to calculate the base level. So instead, we replace the first 4 base levels with the average sales in year 1. And once we know that, to find seasonal factor is pretty easy. First one will be equal to the actual sales in time period 1 minus the level of time period 1. And we can do the same for time period 2, 3, and 4 similarly. All right, that's the initialization of additive seasonality model. Once again, to make sure our forecast will be integer, we're gonna format cells. Make sure they keep 0 decimal place. Now we are ready to use the regular formula for level to calculate the first one. Actually, in this case, will be the level for time period 5. How are we going to do that? We're going to use this formula, but in this formula, we have a parameter called alpha. Once again, we don't know what alpha value will be. So for convenience, we pick 0.5. If you want to pick 0.6, go ahead. In the end, we're going to use solver again to find the optimal values for alpha and beta later on. Okay, let's see how it works. So it's E phi is going to be equal to alpha, absolute cell reference, times Y phi minus S sub T minus P. And in this case, T minus P is what? 5 minus 4, which will be S1. Be careful. And plus 1 minus alpha, absolute cell reference, times the previous level, or E4. And before I click enter, I want to remind you again, here we're calculating E phi, so T is equal to phi. And E phi will be equal to alpha times what? Y phi minus S1. Because T is phi, P is 4, so T minus P is 1. And similarly, E sub T minus 1 will be nothing but E4 because T is phi. Enter. And once we have that, we are ready to calculate the seasonal factor. Use our regular formula over here. So this one, St equals Yt minus Et, does not work anymore. So we're going to use the new formula. It's going to be equal to, okay, right here, S phi will be equal to beta. Beta, once again, for convenience, we assume it's 0.5 at the beginning. Beta absolute reference times Yt, T is phi, so Y phi is in cell D9, minus what? Minus E phi, the number we got a second ago, so it's in cell E9, plus 1 minus beta, 1 minus 0.5, absolute cell reference once again, times S sub T minus P. T is phi, P is 4, so T minus P is going to be S1 times S1 right here. Return. Okay, now we are ready to make some forecasts or predictions. For example, what's going to be the forecast for time period 5 or quarter 1 of 2011? The formula is the last one. And how are we going to use this formula? Okay, since we are looking at predicting sales in time period 5, so we don't know E phi and S phi just yet. All we know is E1 through E4 and S1 through S4. So what we're going to do is that it's going to be equal to the most recent level that is available, which is E4. So we're predicting sales in time period 5, and we know the base level for time period 4, that's the most recent one available, plus what? S sub t plus m minus p. Okay, we are predicting y5 hat, right? And t plus n will be equal to 5. What will be the value for t and n and p? And t will be equal to 4 because that's the most recent time period in which we know the information. So t will be equal to 4. As a result, n will be equal to 1. And what about t plus n minus p? That's going to be nothing but 1, because t plus n is 5, p is 4. So we are looking for what? S1. Where's S1? In cell F5. And it shouldn't be a surprise at all, because we are looking at the prediction of sales in time period 5 or quarter 1 of 2011. So the most similar quarter would be quarter 1 of year 2010. And that's why we're going to use the seasonal factor coming from exactly a year ago. So the forecast would be level of time period 4 plus seasonal factor of time period 1. Return. We get the forecast would be 23. And let's take care of the regular stuff. Forecast error will be equal to actual sales minus forecasts. And absolute deviation will be the absolute value of forecast error. And APE will be absolute value of forecast error divided by the actual sales. And squared error will be nothing but forecast error squared. And once we have that, we can just click and drag it down to finish the calculation for all the remaining 11 time periods. But here we're not done yet. You look at over here. We want to predict sales for time period 5 all the way to time period 20. How are we going to do that? Okay, let's see time period 17. How are we going to predict the sales in first quarter of 2014? So here y17 hat will be equal to what? E16, most recent level that is available. So plus S subscript will be t plus n minus p, but t plus n is 17 right now. P is constant, which is 4. So t plus n minus p would be 13. So we need what? Seasonal factor from a year ago, which would be S13. Return. So our prediction of sales for quarter 1 of 2014 would be 36. But what about time period 18, quarter 2 of 2014? You see over here, we do not have base level from time period 17. The best we got, once again, is this one, E16. So the prediction for time period 18 would be E16 plus the seasonal factor from a year ago. That would be what? Time period 14. Because here we're looking at time period 18. So the seasonal factor from a year ago will be S14. And one way to do that, because we know the base level for future prediction will be time period 16, right? So here we can use absolute cell reference. And then we can copy and drag the formula down. As a result, we get the demand predictions for time period 17 all the way to period 20, or quarter 1, 2, 3, 4 of year 2014. And this is how additive seasonality model works. Let's calculate MAD, MAP, and MSE. MAD is the average of all the absolute deviations. MAP is the average of all the APEs times 100. MSE is the average of all the squared errors. Oh, wait a second. Those results are based on the assumption that alpha is 0.5, beta is also 0.5. And we would like to optimize it. What do you mean? We want to choose alpha value and beta value wisely to minimize MSE. Once again, we're going to go to Data tab, click Solver. Objective, let me reset all. Objective would be MSE, which we would like to minimize by doing what? By changing alpha and beta value. Constraint would be at alpha or beta are numbers between 0 and 1, so they have to be less than or equal to 1. Okay. And by checking this box, make unconstrained variables non-negative, we took care of the greater than or equal to 0 part. Similarly, we're going to use GRG nonlinear method. And we're ready to solve it. What do we find? The best alpha value is 0.55, the best beta value is 1. As a result, MSE is minimized to be 15.